In this lesson, we will be going over 7.2 absolute value functions and transformations. This will be day 1 of our notes. So, what is an absolute value function? Well, it is one of the most recognized piecewise defined functions. It's called the absolute value function. The graph of the absolute value function is composed of 2 linear pieces joined together by a common point called the vertex. So in the previous lessons, we have studied piecewise defined functions, and we have learned that it is linear pieces on a graph with restricted domains. So this is going to be our parent function of an absolute value. So of course, we need to start with f of x equals absolute value of x. Now, how is this a piecewise defined function? Well, if you recall the definition of absolute value, it is the distance a number is away from 0. So for this example, you need to realize that there is a negative x that turns into a positive, and there's also a positive x that is also a positive because it's talking about distance away from 0. So as a piecewise defined function, the negative x is going to be when x is less than or equal to 0, and then the positive piece is going to be everything else which is above 0. So this is officially your parent function, and I need you to concentrate that we're doing the absolute value of x. So as we scroll down here, we are going to do the table and graph, and then we're going to talk about the key features of this graph. Now, keep in mind that this is the parent function. So it is y equals the absolute value of x. So if I complete this table, I have the absolute value of -3. Well, that is the distance away from 0, so that is going to be a +3. And then I'm going to go down through here all the way, and then I am going to evaluate the absolute value of all of these numbers. So here I'm going to get a +2, here a +1, here a 0. Absolute value of 1 is 1. Now notice something just happened. We have now got the same number back into the table. So this is a 2 and this will be a 3. Now I want to highlight this part right here. At this point here, we have numbers that are the same in the table, and we have never had that happen before. So now let's go ahead and look at the graph. So if we graph -3, 3, -2, 2, -1, +1, 0, 0, something's going to happen right here. So we have a +1, +1, 2, 2, and a 3, 3. And you can tell that this is the negative piece because remember the restriction of 0. This was the piece left of 0. And then we have a positive piece, and it goes like that. So I would like to refer back to this piecewise defined function up here. If you look here, this negative x is this piece, and this positive x is this piece. Therefore, it's going to make a V shape. So it's 2 pieces with a restricted domain going through 0. So that is how it is piecewise, but I really want us to just focus on the parent graph here. So that's what I'm really going after, is that it is a V shape. Now, since this is the parent graph, everything that we graph from here on will be similar to this one because it is the parent. So let's go over here and let's analyze this graph by doing the key features of the graph. First, relative min, absolute min. Now remember, a relative min can happen in between endpoints, and then absolute min is absolutely the lowest part on the graph. So if we look right here, this is where 0, 0's at, we do actually find the point 0, 0 right here. So that's going to be the relative and absolute min. Remember, we only report the y value for the absolute or relative min or max. Now, the relative max or the absolute max would be the highest point on the graph. Well, where these have arrows, we do not have an end point. Therefore, we do not have an absolute or relative max. So we are simply going to say none, since this graph opens up and continues forever. Now, the vertex you can see from the table and the graph, the vertex is 0, 0. And now we need to analyze where it increases on the interval. So remember, I always tell you to pretend that you're walking on this graph. So if you're walking here, you walk left to right. You would be decreasing here. We have a turning point here. And then if you were be walking here, you would be walking uphill. So you are increasing on this side right here. So as you go forward on the X, you are going up the line. So increasing over the interval, that is going to be 0 to infinity. Now, decreasing over the interval will be negative infinity all the way up to 0. So this one's going to be negative infinity, comma, 0. Now, keep in mind, I did not use brackets here. I used open always for the infinity, and since 0 is the turning point, I went ahead and left both of those open because you're kind of stationary there, you're constant there. Now, last is the domain and range. I didn't mean to erase that, so let me add that back in there. So the domain and range would be the next thing. And for that, as you can see, the x values here in the table, they go on forever. Therefore, the domain is going to be the set of x's, and it's going to be all real numbers. So we will do that in set notation. And then if I clean this up a little bit so we can see the parent back again. So, whoops, didn't mean to erase that one there. So let me draw that one back. So the range is going to be everywhere the y values can occur. So the graph starts here at 0, 0. It's forever staying up this way and up this way. There's never any values down in here. So everything stays above that. So our range is going to be y is an element of the real number system such that y will always be greater than or equal to 0, close the set. So let's now analyze just overall about the absolute value graph. It is V-shaped. The parent starts at 0, 0, and it has the positive piece and it has the negative piece. All absolute value functions will come from the parent graph. So now let's go down to the very bottom here, and it says compare an absolute value function to the parent function. Now, I'm going to model how to do this, and then you are going to do this process on the back of these notes. So, step 1 says graph the given function using a table. This is the given function. Step 2 says graph the parent function. Step 3 says determine the differences in the given functions compared to the parent function. So let's begin with step 1. Graph the given function using a table. Now, this time I have y equals -4 absolute value x. So in this case, it'll be -3. Now, you have to be careful with absolute value. You have to do order of operations. Therefore, to do this, you have to do -4 times the absolute value of -3, which is 3. So 4 times 3 is negative 12. Now we are going to repeat that process for the next number in the table, which is negative 2. So I have negative 4 times the positive 2, which will give me negative 8. Repeat the process for 1, negative 1. The absolute value of negative 1 is 1. Negative 4 times 1 is negative 4. Repeat the process again for 0. The absolute value of 0 is 0. Negative 4 times 0 is 0. So you can see that I'm simply just doing order of operations. Now let's do the positive numbers. We have 4 times the absolute value of 1. Well, we know that this is simply 4 times 1, which is, and the 4 is still negative, so we still have a negative 4. Now again, notice something happened right there. The negative 4 came back, and then I'm going to repeat this process with a 2 right here. Absolute value of 2 is 2, so this will be a negative 8. And you can predict what the next one will be when I have the 3. It is 4 times the absolute value of 3, so negative 4 times 3 is negative 12. So we've completed the table. Now let's graph the function. Negative 312 runs way off the graph, so it's way down here. So what I'm going to do is I'm going to start with the vertex. So I'm going to plot 0, 0, and then I'm going to plot negative 1, negative 4, and positive 1, negative 4. Now, negative 2, 8 would be way down here, and positive 2, 8 would be way down here. So I think we have enough points to go ahead and graph this. Now, notice the shape. It is still a V, but it does look significantly different than our parent graph. So, step 2 says graph the parent function. Now, recall from the previous problem, the parent function starts at 0, 0, and it had a 1, 1, 1, and a 2, 2, and it went this way. And then recall that it had a negative 1, 1, a negative 2, 2, and it went this way. So that's the parent. That's the V that we're used to. So step 3 says determine the differences in the given function compared to the parent. So how is this red graph different from the green graph? So the first thing I notice is that it is flipped. So it is completely flipped over. And it really flipped over the x-axis. So I'm going to say flipped over the x-axis. Now the next thing I noticed is that it's significantly narrower than that green graph. So we call that stretched out. So it's stretched out, and what happened is it got narrow. Now we can actually figure out why that happened. If you look back up here at our original function, there is the parent. Absolute value x is the parent. In front of the parent is a negative 4. So what has actually happened if I scroll back up and I compare the tables, you can see that these numbers have been multiplied by negative 4, which made it stretch back out. So we are going to actually note that in our notes that this got multiplied by negative 4. So let's go back over this. How is the red graph different from the green graph? It flipped over the x-axis, it stretched out and got narrow because it was multiplied by negative 4. Now, go to your next page of your notes, and you will see that it just says transformations, and that you have 5 problems listed. Now, your job to complete the rest of these notes is to complete all tables for every function that's given. Then you're going to complete the table. Then you will graph the graph. Then you will compare it to the parent. And then you will answer the question of what is changing. So now you will complete these 5 problems and this will